Okay, here is the objective for the Simplifying and Evaluating Learning Objective 1. It's a good idea to have your cheat sheets in front of you. Whenever I do use the cheat sheet, I'll let you know. So for instance, on the first, the first 4 and then number 6, I would be looking at the cheat sheet to help me get through this. So starting with number 1. Number 1, you could go about a couple of different ways. It depends if you want to get everything out of those square roots right now because everything is perfect, or if you follow that orange paper that you guys got in class, which has you get everything under one roof or one radical first. So starting with problem number 1, what I'm going to do is when I look at the directions on your orange paper and it says, do you have several indexes, several radicals, get everything under one roof? That's the approach I'm going to take the first time. So just focusing on the numerator right now, I have a 6 on the outside, but I could, since both things are square roots, I could combine the x squareds into x to the 4th. And keeping up with that continuing process, since the numerator and the denominator both have a square root, what I can do is subtract my exponents. And when I do that, 4 minus 16 is negative 12. And then that negative exponent says it should end up in the denominator. And now what I can do is, again, referring to that orange paper, it says take a quick look, this is step 2, and note anything perfect, especially if it's in the denominator. Leave it for now. Well, x to the 12th is perfect. That has a perfect square root. And if you think about this as being a 2, 2 goes into this 12 6 times. So when it says leave it for now, I'm going to take it out because that's all I have to worry about. So the fraction right now, the 6 over the 81, I'm going to leave. And the square root of x to the 12th, I use a division. 2 goes into 12 6 times. And if you leave your answer like that, that's great. If you happen to notice that you can simplify your 6 and your 81 by taking a 3 out of both of these, that's great as well. Your answer ends up being 2 over 27 with x to the 6th. The other thing you could do is when you look at the problem, a lot of you will probably notice that everything in the square root is perfect and everything can come out. I don't need to necessarily combine this all under one roof. So for instance, the square root of x squared is x, the square root of this x squared is x, and the square root of the 16, again with that division factor, I get x to the 8th. And then what happens is the x's that are on top can combine into x squared. And then when I combine that x squared with the x to the 8th, I'll do this through subtraction again. 2 minus 8 is negative 6, which starts out in the top, but then the negative rule moves it to the bottom. So you end up with x to the 6 in the bottom. And then looking at the 6 and 81 again, if you see that the 6 and the 81 simplify, take a 3 out of both of them into 2 or 27. That's great. All right, number 2. Number 2, I'm going to use my cheat sheet and I'm going to reference the exponent rules. And the first thing it says, deal with any parentheses. That means you're going to multiply your exponents. So this 1/2 is going to distribute to everything, including the 25, which has an exponent. So it's going to go to the 1, the 10, and the 16. So I get 25 to the 1/2. Half of 10 is 5. Whoops, I wrote 10, not A. And half of 16 for the B is 8. And then if you remember, I stressed to you guys 1/2, 1/3, 1/4. Those are all like a square root, a cubed root, a fourth root. So 25 to the 1/2 is like the square root of 25. So I'm going to turn that into a 5 and then just bring the rest along. And that's it for number 2. Number 3, same type of problem. The first thing I'm going to do is deal with my exponent on the outside, and it's going to go to everything. And even the 3 has an exponent and the 2 has an exponent. So starting with the numerator, it's going to go to the 1, the 1/4, the 2/3, and the z has an exponent of 1. So with the numerator, I have 3 squared. 2 times a 4th is 2/4 or 1/2. 2 times 2/3 is 4/3. And I will have z squared. And then I'm going to do the same thing again. I'll move this down a little bit. But this time I'm going to take the 2 and distribute to everything in the denominator. So the 1, the x and the y to the 1/2. So in the denominator, I get 2 squared, I get x squared, and I get 2 times 1/2 is just 1. So in my denominator, I just have y to the first. And then it says to organize. I pretty much have this organized. I have all my numbers grouped together, all my x's, all my y's. So I'm just going to tackle each piece as a little problem. And focusing on the numbers, 3 squared is 9. Denominator 2 squared is 4, and I can't simplify 9/4. For my x's, I would subtract them, and 1/2, take away 2. 1/2 take away 2 is negative 3/2, which starts out in the top, but then the negative says move this to the bottom, and then it becomes a positive exponent. 4/3 minus 1, that's like 4/3 take away 3/3, that's 1/3, which starts out in the top. And then the z has nothing to simplify with, so I'll just leave it. So this is your answer for number 3. All right, number 4. So number 4, again, I'm going to refer to that orange page, or it's in your cheat sheets. The first thing it says is to several radicals with the same index. If the index is the same, put under one roof. It is already under one roof. So what I am going to do, though, is simplify things. And so I would check the 9/2. I can't simplify that. The x squared, the y, the z cubed, none of that can simplify with anything. So what I'm going to do is go to step 3. If you're going to have a radical in the denominator, flip this page over and pick up on step 4, which I am. What I want to do is prime factor now all the coefficients in both the numerator and the denominator. What I'm going to first note, and which it did say in the steps, is note anything perfect. The 9 and the x squared are perfect. So I'm going to note it. I'm just going to leave it for now. So the issue is in the denominator, I need to build this up. 2 is already a prime number. So I'm on step 5, rationalize or build up the denominator. So I'm going to build it up with another square root. I'm going to put an exponent with the 1. And remember, there's a 2 here. So how many more 2's do I need for them to be perfect? I need one more 2 because then I'll have 2 of them. Whoops. And then how many more z's do I need? I need a total of 4. I already have 3, so I'm going to add one more z. Now what I'm going to do is get my denominator under one roof. This is step 6. So that means I have 2 2's and 4 z's. Step 7 says get your numerator under one roof, so I'm going to do that. The 9 and the x squared, I noted were perfect. I underlined those so I don't forget the y and a 2 and a z. And now I'm going to take out all the perfect stuff. So by doing this, I've made the denominator perfect. 2 squared, that comes out as 2. The square root of z to the 4th is z squared. In my numerator, the square root of 9 is 3. The square root of x squared is x. And then I still have some that doesn't get to come out, the 2, the y, and the z. And that's how I would do number 4. All right, number 5. Number 5, there's not a shortcut for. The idea is I'm going to multiply. The first thing I like to do, again, is I like to add the opposite. And I'm going to distribute my x first into the bigger set of parentheses. So when I do that, I get x cubed, and then I get negative x squared, and then I get a 3x. And now I'm going to take the negative 2, and it gets a turn to distribute into everything. And I'm going to line it up with its like term. So negative 2 and x squared is negative 2x squared. Negative 2 and negative x is a positive 2x. And then the negative 2 and 3 is a negative 3. And now I'm just going to add everything up. It's all paired up. So my final answer for number 5 is x cubed plus negative 3x squared, 5x, and negative 3. Or, sorry, not negative 3. That multiplying, I wasn't paying attention. When I multiplied, I should have gotten negative 6. So when I add it up, I get negative 6. Sorry about that. All right, number 6. Number 6, you guys, you can do this problem the long way, which means you should take 2x plus 5 times 2x plus 5, FOIL that, and then when you get from there, take times another 2x plus 5. What you do not do is just distribute in. You can't distribute in an exponent when there's addition or subtraction. You can only do that distributing rule if there's multiplication and division. So again, you're more than welcome to do this the long way. This is a shortcut. You should be looking at the multiplying shortcuts page. And that shortcut tells you to cube the 2x and cube the 5. And they're going to be what start your expression and what ends your expression. So when I cube the 2x, I cube the 2 for an 8, and I cube the x for x cubed. I will be adding two things in the middle. And then I should cube the 5, and that's 125. So these two blanks that I'll be filling out come from this part of the shortcut. It says to do this. And A and B refer to the 2x and the 5. So the first thing I'm going to do is square the A. So that's like me squaring the 2x here. So here goes the 3. When I square the 2 and the x, okay, and then the B is like the 5, and that becomes 3 and 4x times 4x squared times 5. So when I'm done multiplying that, I get 60x squared, and that's one of the things that's going to go in the blank. And now I'm going to do the same, the 3 with a 2x, and this time I'm going to square the 5. So when I break this down, I have 3 times 2x times 25. And when I multiply all of that, I get 150x. And that goes in my other blank. So that's the shortcut, or again, you could do this the long way. All right, let's finish up the first page. 7, it says write an expression for the surface area of the volume in terms of x. So what they want you to do is to replace r with 2x, and they want you to replace h with x squared. So again, r I'm going to replace with 2x, and h I'm going to replace with x squared. So the volume is 1/3 in pi, and the radius squared, so I'm going to replace the radius with 2x. There's the radius squared, and then times the height, which is x squared. And now my job is to clean this up. So when I'm simplifying, first I'm going to deal with the exponent, the parentheses. And so I'm going to square the 2 and the x. So that gives me 4x squared along with the other x squared. And now I'm going to combine my x squareds here. That's just x to the 4th. And I'm going to multiply the 4 and the 1/3. So when I do that, that's just 4/3 and then the pi. So this is what you get for number 7. That's the expression for the surface area in terms of x, meaning everything has x in it instead of the r squared and the h. All right, number 8, write the equation for the circle. You're going to be completing the square. So in the completing the square part, when we talked about this, we grouped our x's, we grouped our y's, and we moved our constant to the other side. So here is me grouping my x's. I'm also going to be leaving a blank for the completing the square part. I'm grouping the y's now. I'm going to add the opposite on that -8y. And give me a moment. I'm going to move this all over a little bit. And when I'm done, this is all going to equal 12. I'm going to add 12 to the other side. So what I'm going to do first is I'm going to focus on the x's. So I'm going to do my completing the square here. So I take b, which is 6. I cut it in half, which is 3, and then I square and I get 9. And 9 is what goes in the blank here. And I forgot to add my 2 blanks over here. I'm going to squish them in this way. 9 on this side. And then I'm going to do the same thing, but this time I'm going to do this for the y's. So completing the square for the y's, I take the -8, I cut it in half, that's -4. I square and I get 16, and that's the number that's going to go in the blanks, one on the left, one on the right. So as far as the right side goes, I can go ahead and add up the 12, the 9, and the 16, and that becomes 37. In the equation of a circle, I have a set of parentheses with x. I have a set of parentheses for y. and I figure out the number, and the number that goes in here is what b was cut in half before you squared it. So 6 cut in half, that's 3. -8 cut in half, that's -4. And now you have your equation of the circle. So same thing happens on 8b. We'll just go through it one more time. So the first thing I'm going to do is group my x's and group my y's. Oops, here we go. There's the blank for completing the square. And now I'm going to do the same for the y's. But what I notice, the y's on the other side. So I'm going to add it to the left side. Add the opposite on the -28y. And now I'm going to move the 21 over to the other side. And here goes those blanks that I have to add as well. So first I'm going to start with the x's. I'm going to take b, which is 18. I'm going to cut in half. That's 9. And 9 squared is 81. That goes in the blank. And it goes in the blank on the right. And then same for the y's. Whoops, should have brought the blank a little further over. I'm going to take -28. I'm going to cut in half. That's -14. I'm going to square it. And when I'm done squaring that, I get 196, which goes in the 2 blanks. And I'm going to clean up the right side first. I'm going to add the -21, the 81, and the 196, and I get 256. I'm going to make my 2 parentheses, one for x, one for y. And again, the number that goes in there is my b cut in half before I square it. So 8 cut in half, that was the 9, and -28 cut in half, that was the -14. And then I've got my equation of the circle. I could see the center, it's 9, I'm sorry, -9, 14, and I can see the radius, whatever the square root of 256 is. All right, let's take a look at the next page. So this was definitely a tougher section for you guys when we took this on the test. We're going to be creating some new functions. You're going to be either adding or subtracting, multiplying, or doing composite functions, which means you take one function and you put it into the other. So starting with 8, g of x over f of x. So g of x is 3x squared, f of x is 2x plus 4. I'm just going to take, g of x and put it over f of x. And then my job is to look how I can simplify this. This is it. You cannot, for instance, as some of you might want to do, get rid of an x, like cross this one out and cross this one out. Because now in the denominator, what you're doing is you're breaking up addition, subtraction. So one thing that Mrs. Diekfu says, that's a good way to remember this, is when you set it up, she says put parentheses around it. She calls it hugging it. And the only way you could break it up is if you factor something out. So in the denominator, I could factor out a 2. And in the numerator, I could factor out a 3. But again, if it's in parentheses, either all of the parentheses come out or none of it comes out. So the x squared's in parentheses, the x plus 2 is in parentheses. It's staying out that way. And I can't take out the 3 and 2 because they're not the same number. So you can just leave it as it is. All right, let's take a look at number 9. 9 is a composite function. The way this is presented to you is it says it wants you to take g and put it into h. So with this problem, I'm going to take g and I'm going to put it into h. And when it goes into h, when this goes into here, it's going to go into x. I'll still keep the 1/4 and I'll still keep the 5. So I'll still have the 1/4, but instead of x, I'm going to make it 3x squared, and then there's the plus 5. And now to clean this up, what I would do is I could multiply my fraction of 1/4 and 3x squared. So when I multiply that, I get 3x squared over 4, and then add the 5. And that's it. Adding, subtracting is very picky. I can't add those because they're not like terms. Let's jump to number 12. These are not quite put in numerical order. So in number 12, what I'm supposed to do is take f of x and subtract g of x. So again, when I write this down, I'm going to put it in parentheses. So f of x is 2x plus 4 minus g of x, which is 3x squared. I am going to add the opposite. And when I do this, I'm now going to drop the parentheses. And my job is to simplify this. I cannot add the 2x and the negative 3x squared. They are not like terms. So the best I can do is just write it in standard form. So the x squared goes first, then the 2x, and then the 4. And that's it. That's all you can do with number 12. All right, number 10. So the way number 10 presents itself is this is saying they want you to take h and put it into f. So this h is going to go into f. And when this goes into here, it's going to go into x. The 2 will still be there and the 4 will still be there. So here's the 2, and in for x will go the 1/4 x plus 5, and then the plus 4 is still there. And now my job is to clean this up. So I will distribute my 2. 2 times a fourth is 2/4, which is also just 1/2. With the x, 2 times 5 is 10. And then I have the 4. And now what I can do is combine the like terms of 10 and 4 so that when I'm done, I have 1/2 x plus 14. And that is it for number 10. Number 11, another composite function. This is saying to take g and put it into f. So when I do this, g, all of this is going into f. And when it goes in here, it goes in for the x, and the 2 and the 4 stay. So here's the 2. And in for x is 3x squared. And then I still have the plus 4. Now I'm going to clean this up. I'm going to multiply the 2 and the 3x squared and add the 4. And that's it. I will leave my answer as such because they are not like terms. Multiplying, you can do more combining. Adding, subtracting, you can't do that unless they're perfectly like. Adding and subtracting is very picky. All right, my last two. I need to take f of x and multiply it with h of x. So I'm going to write it again in parentheses like I've done on a couple others. So here's f of x. Here's h of x. And you can think of this as foiling. I'm just going to distribute. First, I'm going to let the 2x distribute in. And 2x and 1/4 x, well, the 2 and the 4th is 2/4 or a half. So a half. And when I multiply the x's part of it, I get x squared. 2x with 5 is 10x. And now the 4 gets a turn. So 4 times 1/4, just 1. 4/4 are 1, so I'm just going to write an x. And 4 times 5. And now my job is I'm going to combine my like terms. And the only thing I can combine are my x's. So I get 1/2 x squared plus 11x plus 20. And that's 13. All right. 14, we're getting into logs. So expanding, I want to go from one log to several logs. So I'm going to leave that x plus 4 in parentheses. Right now it's x times x plus 4, and then divided by x to the 7th. I'm changing my addition subtraction into multiplication. I'm changing my multiplication division into addition subtraction. So this times becomes a plus. The stuff in parentheses is protected. The division becomes subtraction. And now each of these terms, this is a term, this is a term, this is a term, they're each going to get their own log. So the x gets its own log, the x plus 4 gets its own log, and the x to the 7th gets its own log. But the 7, remember, moves to the front of its log. So, sorry, there wasn't an x there. Yeah, that's right. So that's how that one ends up. Let's do 15. So 15, I would look at my cheat sheet. I would look at my formulas for exponential growth and decay and compound interest in this. And this says compound quarterly. Quarterly means 4 times a year. So the formula says you take your initial amount, which is $370. You do 1 plus your rate, which you have to put as a decimal, that's 0.04, over n, which is 4. And then n appears again in the exponent along with the number of years. So at this point, you would just want to use your calculator. And remember, you got to wrap this in an extra set of parentheses. And some of you might have to put your exponent in parentheses. When you're done doing this, you get $1,490.03. 16, you're going to rewrite it as an exponent. That means you're just looping, getting ready for the solving part. So it just loops 6 to the x power equals 216. And that's all you have to do. I don't ask you to tell me what x is, so that one's done. 17, I'm condensing. So here I'm going to go from several logs down to one log. So I'm going to temporarily ignore the logs. And I'm going to remember that this 2 moves back as an exponent. And when I look at it now, it's 32 minus x squared plus y. And the subtraction will turn into division. And the addition will turn into multiplication. And now it's 32 divided by x squared times y. Now, the y goes in the numerator. It does not go in the denominator. Anything that's divided is in the denominator. Anything that's multiplied is in the numerator. What I could have done is just move the y into the front, and then you guys would see that. But it's condensed, and now I'm going to bring that log back, and this is your answer for 17. 18, same problem, condense. I'm going to go from one log to several logs. So I will be ignoring the logs temporarily. I'll be moving the multiplied numbers to the back as an exponent. So I see this as 2 to the 7th plus x to the 5th plus y cubed. All that addition becomes multiplication. 2 to the 7th, I guess you could leave it like that, but it is worth 128. It's been condensed, and now I just went from 3 logs down to 1 log. Bring the log back. And that's 18. All right, final page. This is with our sequences and series parts. So you will want those notes in front of you. The first 4 problems want you to write the rule for the following sequence. I would suggest you see if it's arithmetic or geometric first. So arithmetic means it's going up or down by the same amount through addition or subtraction. So when I go from -4 to -2, they're adding 2. From -2 to 0, they're adding 2. 0 to 2, they're always adding 2. So that's your D. The other thing you need to use to write a term or a rule is the first term. And that's -4. And then using the formula in front of me, it says to find any term. The rule would be I take my first term plus D with n minus 1, and then you do your 2 steps. You distribute. I'm going to add this as -2, and then you combine your like terms, and this is your rule. So now I can find any term, 2n plus -6. All right, 17, is it arithmetic or geometric? First check arithmetic. That's going up by 6. This is going up by 6. This is going up by 6. Everything's going up by 6. So that's your D. And your first term is 1. And now you can write your rule. To find any term, you need your first term plus D and n minus 1. I'm going to do the 2 steps of distributing first. Again, I'm going to add the opposite. And then I'm going to combine my like terms of 1 and -6. So when I'm done, I have 6n plus -5. And there is my rule. All right, 21, is it arithmetic or geometric? First time it's going down by 4, then it's going down by 6, and then it's going down by not 4 or 6. So this is not arithmetic. So now I'm going to see, is it geometric? So I'm going to work backwards, and I'm going to start to create these fractions. So -27 over -18, -18 over -12, -12 over -8, and as it turns out, they're always worth the same amount. They're always worth 1.5, and that's your R. That's your ratio. So since it's geometric, you need R and your first term, which is -8, and then you can write your rule. So to find any term, you take your first term with R to the n minus 1 power, and that's it. There's no cleaning up. You don't multiply the -8 with the 1/2. It stays separate. All right, 22. First thing I'm going to see is arithmetic. So this goes up by 6. 8 to 32 does definitely not go up by 6. So now what I'm going to see is it geometric. So 128 over 32, 32 over 8, 8 over 2. As it turns out, I'm always getting 4, so that's your R. And then again, to write the rule, I need the first term, which they give me. And now to find any term, I can take the first term times R to the n minus 1, and that's it. Your rule is done. All right, let's take a look at 23. It says write the following sequence using summation notation. Well, the first thing you're going to have to figure out is the rule. So again, is it arithmetic? -5 to 5 is adding 10. 5 to 15 is adding 10. 15 to 25 is adding 10. So it's arithmetic. I got my D, and I got my first term of -5. And now I can write my rule. It is to find any term. I take the first term plus D with n minus 1. I'll distribute. I'm going to absent here, and then I'm going to combine my like terms. So I have my rule now. So summation notation means you put that backwards E, sigma. You put your rule behind it. And I have to write the range of the terms. So this started with the first term, and it ended with the fifth term. And that's how I would write that problem, 23. 24, it wants you to find the next term in the sequence and write the rule. So if I just have to find the next term, if you notice, it's going up by 3, then it's going up by 5, then 7, then 9. So the next one would go up by 11. So if I just take 26 and add 11, I get the 37. I don't need a rule to do that. I can just see the pattern. But for the rule, we'd like to see if it's arithmetic or geometric. And it's not arithmetic because it's not always going up by the same amount. So then I could see is it geometric. Just working with the smaller numbers, 5 over 2 and 10 over 5 are not the same amount. So it's not geometric. So what I would do in this problem is put the term number above it and try to figure out, well, what are they doing from 1 to get to 2, 2 to get to 5, 3 to get to 10, 4 to get to 17. Some people are going to be good with this. Maybe what you notice is these are all just one more than a square, a perfect square. 5 is one more than 4, 10 is one more than 9, 17 is one more than 16. And I can get 5 or 4, for instance, on the 2 right here by squaring the 2 and then adding one more. And I can get 4 to 17 by squaring the 4 and adding one more. So the rule would be that they just square the term number and add one more. They're going to get the term that goes with it. Okay, next thing on these, again, you want to use your shortcuts. The first thing I'm going to do is mark, what are they, arithmetic, geometric, or 1, 2, 3. So 25 is geometric, and the way I know that is because the variable is in the exponent. So I'm going to put a G. Ones that are similar to that one, 29 is like it, and so is 30. My arithmetic ones are a line. So if it's mx plus b, so 4 plus I, and number 26 is like 1x plus 4. That's arithmetic. 2 minus 7i is like negative 7x plus 2. That's arithmetic. And then 28. 28 is one of those 1, 2, 3. It's number 3, but it's slightly modified. The third rule is just I squared or x squared as it is in the rule. So I'm going to modify this. Once I'm done, I'm going to take my answer times -1. So 25, let's start filling this in. On 25, what you need to know is the first term. And I get the first term by putting 1 in here, and -3 to the 0 power, anything to a 0 power is 1. So the rule goes, you take your first term, which is 1, and then in parentheses, I'm going to have a numerator and a denominator. It goes 1 minus -3, and then also 1 minus -3. But in the numerator, I need an exponent behind my -3, and that's the number of terms. And if I just subtract the 8 minus 1, which is 7, and then add one more back on, that's the number I need here. So it's the 8th. And then we talked about not to type this all into your calculator. In the denominator, if I add the opposite, I get a 4. So now what I would do is get your calculators. It doesn't have to be a graphing. I would take 1 minus -3 to the 8th power. I'd hit enter. And then I would take that number and I would divide it by the 4, and I would hit enter. And then, not that you need to, but the next step would be taking it times 1, because multiplying by 1 is not going to change the answer. And when you're done, you should get -1,640 as your answer. All right, 26 is arithmetic. What I need on this is the first term and the last term. The first term comes from me putting the 3 in there. So 4 plus 3 is 7. And then I need the last term, which means I'm going to put 17 in there. And 4 plus 17 is 21. You divide by 2. And then I need to multiply by the number of terms I would be adding if I did do this the long way. So again, subtract those. 17 take away 3 is 14. Always add one more back on. When you type this into your calculator, if you are, remember, you got to get that number in parentheses first, the 7 plus 21. But when you're done, you get 210. 27 is also arithmetic, so I need the first term. That comes from me putting a 1 into here. So 2 minus 7 is negative 5. I need my last term. That comes from me putting 25 in there. So 2 minus 7 times 25, you get negative 173. It's divided by 2. And then the number of terms, when I subtract 25 minus 1, that's 24. Add one more back on. And again, if you're going to try to type this whole thing in your calculator, you need parentheses here. And when you're done, you get negative 2,225. All right, last row. On 28, this was one of the shortcuts. So when you use the shortcut of I squared, you need to know what's the highest term number you're being asked to put in there, and that's a 10. And the rule says you take 10 plus 1, and then 2 times 10 plus 1, and then you always divide it by 6. Now what I'm going to remember is this negative 1 that is not part of the rule is now going to be multiplied into the rule, and so when you're done you get negative 385 after you type that into your calculator. 29 is also geometric. I need to know the first term. The first term comes from me putting a 0 into here. So anything to a 0 power is 1. So there's my first term. And then my parentheses for my fraction, 1 minus r. R is negative 2. Remember, r is the one attached to the exponent. And in the denominator, 1 minus negative 2. And then the number of terms I would use the long way is if I take 14 minus 0, that's 14. Add one more on, that would be 15 terms. So again, I'm going to add the opposite, get the denominator to a number. And now I'm going to let my calculator do the work. Type this in as you see it. Wrap that negative 2 in parentheses. 1 minus negative 2 to the 15th power. Hit enter. And then I'm going to divide by 3. Hit enter. And then it's always a good idea, because that might not always be 1. Take it times 1. And when you're done, you get 10,923 is your answer. Final problem. This is also geometric. For the first term, I need to put 1 into here. So when I put 1 in, that's a 0 power. 5 to the 0 power is 1, and 1 times 2 is 2. So I have my first term, parentheses for my fraction, 1 minus r, which is 5, denominator 1 minus 5. And then here my exponent from 10 to 1. 10 minus 1 is 9. Add one more back on. That's 10. Get my denominator down to a number. And now with my calculator, 1 minus 5 to the 10th power, hit enter. Divided by negative 4, hit enter. Take that times 2, hit enter. And you get a very large number. You get 4,882,812. And that is your simplifying review. This part of the final will be on day 3 of when I see you next week. So depending on your class, that will either be a Wednesday or a Thursday.